This is the sixth video lecture series of home solar system design. In this video lecture, explain about the design and sizing of different components of the home solar system. The main components of a home solar system are the solar panel, the electronic management system or simply the inverter, the battery bank, and the load or the appliances connected to the consumers. During the daytime, the solar panel converts the light radiation into electrical energy. The solar panel produces a DC voltage, which is converted to AC by the required voltage and frequency by the inverter, and which is supplied to the load or the appliances that is connected to the consumers. During the daytime, the energy produced by the solar panel is also used for charging the battery bank. The electronic management system regulates the voltage from the solar panel such that it will be required to charge the battery bank. The ampere hour capacity of the battery bank is very important because it determines how much time the battery will be supply power to the load. And during the night time, the energy or the charge stored by the battery will be supplied power to the load or the appliances of the consumers through the inverter. So the inverter converts this battery voltage into a AC voltage with the required voltage and frequency, and it will be given to the load of the consumers. So there are two requirements for the solar system design. First one is find out the size of components such as the solar panel, the battery, and the inverter. So we have to select the components in such a way that it will be get the efficient utilization of the electrical energy. So we have to select the ratings of the solar panel, ratings of the battery, and ratings of the inverter, which depends upon the power and energy ratings of the appliances which is connected to the home. The second one, the power and energy requirements of the appliances have to be properly matched. Then only the efficient utilization of the electrical power from the solar panel must be fulfilled. So we have to starting from the basics. So for the home solar system design and sizing of the different components of the solar system, we have to calculate first the total power and the total energy consumption of the home. So the appliances, you have to calculate the power of each appliances which is connected in the home and calculate the total power. And also approximately you can calculate the per day usage of each appliances and the per day energy consumption. Adding the per day consumption of all the appliances, you will get the total energy consumption of the home per day. So from the table, we can select the total power as 1785 watts and the total energy consumption per day is 9110 watt hour, or we can say that 9.1 kWh or 9.1 unit per day. So for example, we can assume that the home utilizes 9.1 units or 9.1 kWh per day, and the total power of the appliances connected to the home will be 1785 watts. From this data, we can proceed for the selection and rating of the different components. So the total power will be 1785 watts and total energy consumption will be 9.1 units per day. These two are the important factors for the design of the home solar system. So the power flow or energy flow is from the solar panel to the load, but the sizing of the components and selection of the rating of the different components is in the reverse order. That is, we can calculate the power of the appliances that is connected to the home and energy consumption per day, and from this data we can proceed the ratings of the inverter, battery, and calculate the ratings of the solar panel. So we already calculated the total power will be 1785 watts, and the total energy consumption per day is 9.1 kWh or 9.1 units. So the first one is the selection of the inverter. How you can select the inverter? The inverter ratings will be normally specified in kVA or VA. So normally the practical ratings available are 1 kVA, 2 kVA, 3 kVA, 5 kVA, and accordingly. Similarly, less power ratings are also available. So in our case, the inverter rating has to be selected according to the total power consumption. So the total power consumption will be 1785 watts. So you have to select an inverter which will be just higher the power rating of the appliances. So we can select the inverter with a 2000 VA or 2 kVA. That is the first part. So first one is the selection of the inverter. So the total power will be 1785 watts. So we have to select the inverter. Just the total power will be little higher than the power of the appliances connected to the home. So we can select the inverter rating as 2 kVA. So the next part, there are some losses will be occurred in the inverter. So normally we have to consider losses in the inverter and calculate the input energy supplied to the inverter. In this case, we can assume the 20% losses in the inverter. So the total energy consumption per day is 9.1 kWh, that is 9.1 units, and consider 20% losses in the inverter. The input energy supplied to the inverter will be 9.1 into 120%, or we can say that 9.1 into 0.2, that is a 1.8 kWh more than the total energy consumption. So the input energy supplied to the inverter will be the total energy consumption plus losses. So 9.1, and we can assume that the 20% losses. So 1.8 kWh or 1 point energy will be the losses in the inverter. So the total input energy supplied to the inverter will be 10.9 kWh or 10.9 units. So that is the first part. So you can take a look at the picture. The inverter selection will be 2 kVA. So there are some losses in the inverter, and the input energy supplied to the inverter will be 20% more, that is 9.1 plus losses, that is 10.9 kWh per day. Then next one is the selection of the battery bank. So normally in the home solar system, we are using the lead acid battery with a depth of discharge will be 50%. So the energy storage required for the lead acid battery will be the input energy required by the depth of discharge. So if you have to store, or the energy required by the battery will be 1 kWh, we have to store double than that of, that is 2 kWh will be stored, then only we can supply the 1 kWh power to the load. Similarly, here the battery storage required will be 10.9 kWh and the depth of discharge will be 50%. So battery has to be selected in such a way that the stored energy in the battery will be the batteries, the energy required by depth of discharge, that is 10.9 by 0.5, that is 21.8 kWh. That is, we have to store the double the energy required for the load. So our energy requirement will be 10.9, And the battery, therefore the battery, the lead acid battery has to store double the energy, that is 21.8 kWh or 21.8 units of energy has to be stored by the battery. So we already know the battery rating will be in voltage. One of the parameter will be voltage and another parameter will be the ampere hour. So voltage into ampere hour, that is the energy. So we can select different ratings of the batteries. So normally the 12 volt, 24 volt will be the voltage rating. 60 Ah, 80 Ah, 100 Ah, 200 Ah will be the ampere hour ratings. So here we can select a battery with 12 volt and 200 Ah battery. So the energy consumption will be 12 volt into 200 Ah, that is 2.4 kWh. So our battery storage required will be 21.8 kWh, and we have selecting a battery with the 2.4 kWh. So the number of batteries required will be 21.8 kWh by 2.4 kWh. That is 9.08, or we can use 9 batteries of rating 12 volt 200 ampere hour. So that is the second part, that is the selection of the rating of the battery. The battery selection or rating of the battery is very important, because how much time the power will be supplied to the load will be depend upon the battery ratings. So next part will be the solar panel design or rating of the solar panel. So we are considering input to the battery, that is considering as 50% losses in the battery. So the 10.9 will be the input energy that is required by the inverter. So we have to consider at 15% losses. So the input to the battery will be 15% more, that is 10.9 plus 15% of losses, that is 1.6, that is 12.5 kWh per day. So we are also in some protective systems, protection system will be there, and there also a regulator will be there in the electronic management system. So we can assume approximately 4% losses in the electronic management. Therefore, the energy for the solar panel generate per day is equal to 12.5 plus, that is 4% losses in the electronic management, that in 13 kWh per day. So we can, once again, we can go to the picture. So the 10.9 kWh per day will be the energy required by the input of the inverter. So we are considering 15% losses in the battery bank. So the input to the battery will be required will be 12.5 kWh per day, and there is a 4% losses in the electronic management system. That is, it will be consist of an inverter, that is a regulator, and some protection devices. So 4% losses will be also considered, and 12.5 kWh per day plus 4% losses, that will be 13 kWh per day will be the energy generated by the solar panel, or the required energy generated by the solar panel will be 13 kWh per day. That is the input power required. So we can go to the solar panel design. The losses, we have to consider the losses in the solar panel. So now we are considering as 25% losses in the solar panel. So extra 3.25 kWh per day will be added. So the total energy generated by the panel, considering losses in the solar panel, it will be 13 plus 3.25, that is 16.2 kWh per day. So the solar radiation will be depend upon the different location, or it will be vary from the location, that is approximately 4 to 7 kWh per meter square per day is the solar radiation at different locations. So from the internet data, you can get the correct solar radiation at a particular location. So now we can assume that the solar radiation at the particular location will be 5.5 kWh per meter square per day. And the standard test condition of the solar panel will be 1000 watt per meter square. Then from these two data, the solar panel radiation at a given location will be 5.5 kWh per meter square per day. And from the standard test condition of the solar panel, it will be 1000 watt per meter square. From this data, we can calculate the hours of solar radiation. Then 5.5 kWh per meter square per day divided by 1000 watt per meter square, or 1 kW per meter square. So that is equal to 5.5 hour per day. So per day, the power will be 5.5 hour per day. The hours, that is the solar radiation. So the power of the solar panel has to be calculated. So the required power generated, or the power requirement by the solar panel, will be 16.2 kWh per day, or it is the required power for meeting the requirements of the load of the consumer. So the power of the solar panel required will be 16.25 kWh per day divided by 5.5 hour per day. That is 2.95 kW is the power required by the solar panel. So we are calculating from the firstly the power of the appliances connected in the home, the total energy consumption per day. From this data, we can select the ratings of the inverter, the ratings of the battery, and ratings of the solar panel. So the solar panel ratings we can calculate it as 2.95 kW. So different power ratings panels are available. Accordingly, you can select the panel. So the sizing of the panel will be very important, or area requirement will be also very important. So according to the dimensions, you can select the different power panels. So in this case, we take 250 watt panel from the market. So the number of panels required will be the total power requirement, that is 2950 watts, or 2.95 kW by 250. That is the 12 panels of the 250 watt will be required. So this is the solar panel design. So we can select the ratings of the inverter, then ratings of the battery bank, and rating of the solar panel considering the losses in the system. So this is the normal practical schematic diagram of the grid tied solar system. So in this video lecture, I will be explain only about the home solar system. So just to give you a brief idea of the grid tied solar system. So we can connect the solar system to the KSEB grid or utility grid without any storage requirements. So in this practical system, this has to be installed in the college. So there is a solar PV panels, a DC fuse will be there, then disconnect switch and DC surge protection devices, DC to AC grid tied inverters, then manual disconnect switch. There is a solar meter to measure the power requirement or the energy produced by the solar panel, AC disconnect switch, the consumer distribution panel, then relay operated automatic disconnect switch, a bidirectional meter for calculating the exporting of power and the importing of power and to the distribution network, and the consumer distribution panel, it will be given to the consumers. So this is the final part of the home solar system design. I think all of them are safe, and beware of your health, and thank you.